Alright guys, we are in section 4.3 now, which is titled Computation in Positional Systems. It's kind of a fancy title for just being able to add, subtract, multiply, and divide in other bases like we've been looking at. And so we just want to be able to do the basic operations within other bases. And again, these other bases come in when you might, if you're perhaps studying computer science, looking at history, like we've been doing with some of the past civilizations and cultures and so on. There's such a thing as clock math. There's just several things where, several areas where other bases come into play besides our normal decimal number system. So we're going to begin in a logical place. We're going to start looking at addition. And so here's an example. If we were wanting to add 3-2 base 4 and 2-2 base 4, we would kind of lean on our base 10 number system a little bit in doing that. But of course it would be just like adding in our number system. And so we're going to begin with adding the ones column. And so if we add the 2 and the 2 in the ones column, we're going to get 4. However, we need to remember in base 4 we don't have the digit 4. We only have the digits 0, 1, 2, and 3. So we need to rewrite that 4 to be 1, 0. We're going to carry over into the 4's column with a 1 and have 0 1s left over. So when we add the 2 and the 2, we're going to get that 1, 0. So because it's a 1, 0, we're going to have to carry the 1. It would be just like if we got 10 in our number system. We would have to carry the 1 and write down the 0. So we're going to do that here. So when we add the 2 and the 2, we get 10, but the way we write the 10 is by putting a 0 in the ones column, carrying the 1. All right, so now we are ready to add that next column. We're ready to add the 4's column. So when we add the 1, 3, and the 2, we get 6. But again, we don't have 6's in base 4, and so we need to convert that to base 4. Well, a 6 is 1, 4, and 2 1s, or in other words, 1, 2, base 4. So because we don't have any other columns that we're adding up or whatever, normally if we kept going, we would carry the 1 and write down the 2. But because we don't have more columns we're adding, we're just going to write down that 1 and 2 next to our 0. So our answer to this particular addition problem is 1, 2, 0, base 4. All right. So this example, in addition to the ones in the book, maybe you can use those in order to do the problems in the homework assignment. Okay, let's jump to subtraction now. So here's an example in subtracting in base 6. So we want to take 2, 5 base 6 from 5, 3 base 6. That's our subtraction problem. And so we begin again by subtracting the ones column. But there's a problem here. We can't subtract 5 from 3, just like we can't do that in base 10. And so we have to borrow. And so borrowing is a little bit different in other bases. Normally in our number system we would borrow a 10 from the next column because it's base 10. But here we're borrowing a 6. So as we go to subtract the 5 from the 3, we have to cross out the 5 in the upper number, and because we're going to borrow from that. So we change that to a 4, just like we normally do. But because we're borrowing a 6, we're going to add that to the 3 below it, and instead of that 3 now we have a 9. Okay, again you have to compare that to the decimal number system. So we're ready to do our subtraction finally. And so we would subtract our 5 from 9 and get 4 in base 6. And we would also subtract the 2 from the 4 and get a 2. And so our answer to this problem is 2, 4, base 6. All right? So the trick there is just understanding the borrowing concept. We're not borrowing a 10 like we do in the decimal number system. We are borrowing a 6 because we're in the base 6 number system. So whatever problems you have in the homework, you just have to keep in mind what base you're in. All right? Okay, let's go to multiplication. So now we are looking at an example of multiplication in base 7. We want to multiply 4, 5 base 7 by 3 base 7. And again, the problem starts out basically the same way as it would in a decimal number system. So we're going to begin by multiplying the 3 and the 5, first columns. And so 5 times 3 in base 7, we're going to essentially do that multiplication in base 10 and then convert it back to base 7. So when we multiply 5 by 3, we would get 15 base 10, but 15 is 2 7s, which would be 14, and 1 1. And so we're trying to convert that to base 7 by finding out how many 7s go into 15. 2 of them do. And so we would have 2 7s and then 1 left over. And so that number would be written as 2 1 base 7. Okay? Again, you got to get used to those conversions. All right, so as we do that multiplication, multiplying that first column, 3 times 5, we would get a 2 1 base 7. All right? So our next step would be to multiply the 3 times the 4. So when we multiply 4 by 3 in base 7, we would get 12 in base 10. 4 times 3 is 12 in base 10. But again, we have to convert that back to base 7. Well, there's only one 7 in 12, and so we would take out that 7 and there would be 5 left over, and because 5 is less than 7, we're okay in base 7. And so to convert 12 in base 10 into base 7, we would get a 1 5. So that 12 that multiplies really becomes a 1 5 in base 7. Okay? And again, you have to remember how the algorithm in our normal number system works to do this multiplication. So the next step would be that we would have our multiplication from before, and then to get that 1 5 base 7 in there, remember, some people write a 0 there to remember that we're moving over. We're multiplying 3 by the next column, 4. Some people write a 0 there. Some people don't write a 0 there, and they just move the digits over and leave a holding place there. So however you do that in base 10, however you were taught to do that normal multiplication, that's the way we would do it here. I'm going to go ahead and use a 0 to make sure that we see that that's a placeholder. Okay, and so that 3 times 4 gives us that 1 5 with a 0 placeholder. Okay, and the next step in multiplication then, remember, is to add those. So we are going to add, and we get 171 base 7. However, that presents another problem because we don't have 7s in base 7. And so we have to convert that 7 in the middle. We essentially have to carry that over into the next column, gives us 1 more in the next column, and brings that middle column to a 0 because it's just an even 7. So that 171 becomes a 201 because that 7 in the middle converts over to the next column. Again, you got to remember all this in base 10 and compare it to that in the same process. Okay, so a couple things there that made that something that you just have to remember in our conversion process and so on, in what base we're in. All right, our last example, our last operation is division. So some people may have a little bit of fear of long division from elementary school days and so on, but we just, again, need to remember that process of how to do long division in base 10 in order to do it in other bases. So our example here is going to be in base 4. So we want to divide 112 in base 4 by 2 base 4. All right? So just like in base 10, we have to look at the first 2 digits there because 2 doesn't go into 1 by itself. So we need to figure out how many times 2 goes into 1 1. So we're going to figure that out by doing some multiplication here. So in order to figure out where that 2 goes into those first 2 digits, well, if we compare 1 times 2 in base 4, of course that's 2. If we go 2 times 2, that's 4 in base 4, but again we don't have the digit 4, so we have to rewrite that, and that is 10 base 4. Well, that 10 is going to be as close as we can possibly get to the 1 1 without going over. So we want to multiply by 2. In other words, 2 goes into 1 1 2 times with as close as it can. So this will be the closest we can get without going over. So as we do that, we will multiply by the 2 that we figured out to essentially get a 4, but that 4 is written as 10. So we write the 2 on top, and remember, you line up the digits in the right columns when you're doing division. And so the next step in long division is to multiply those two things. So we multiply 2 times 2, and in base 4 we get 10. Remember, in long division, the next step is to subtract those two things. So when we subtract those, we just get a 1 left over. 1, 1 minus 1, 0 is just a 1. Remember, the next step in long division is to bring down that next digit. So we're going to bring down that 2, and we start all over again. So we have to figure out how many times we can take 2 into 12, or 1, 2, in base 4. Well, we know it's bigger than the 2 that we used before, so let's try 3. So if we go 2 times 3 in base 4, that's 6 in base 10. Let's convert that to base 4 to figure out what that is. And if we do a 6 base 10, well, that's 1 4 and 2 1s. And so 6 in base 10 is 1 2 in base 4. Well, that's what we were shooting for. We had a 1 2 that we were trying to multiply into. So the 3 that we multiplied goes on top, and we do that multiplication. 3 times 2 gives us 1 2. That's what we just did on the side there. And again, the next step in long division is to subtract, and so 1 2 minus 1 2 is going to give us a 0. So this went into it evenly, and therefore that's our answer. 1 1 2 base 4 divided by 2 base 4 is 2 3 base 4. And so it really is a matter of breaking down these bigger problems into smaller steps and just doing the step-by-step process of getting to the overall answer. All right? So hopefully these examples helped in order for you to be able to do some of the problems that are in this assignment, assignment 4.3 in my math lab. If you have any questions, just email me.